Hi, my name is Christina, and this is a quick explainer video on parallel computing with Hub. Parallel computing with Hub enables you to accelerate your data processing on local machines or on multiple clusters. And in this video, we will go over current and efficient ways of processing every image in a large dataset, how Hub processes every image in a large dataset in faster and a more efficient manner, and how Hub can scale computations to large numbers of clusters. Let's imagine you have a dataset stored in S3 with 1 million images, and you want to process all the images in some way and save that in a new dataset. For example, you might want to make all the images black and white. Without Hub, this would be the process of doing the task outlined above. There would be a for loop that will write every item from the dataset in order to make the item black and white. And this is very inefficient for large datasets. And to make the process more efficient, you can run this job on multiple servers. In this scenario, we have a dataset on S3 with 1 million pictures, which is stored in a zip file. And we can send this data to 10 servers, so we will need to download the entire dataset on every single server. And then each server will discard other parts of the dataset, so each server will only keep 100,000 images in this case. Then data processing will take place on each server, and once all the data is processed, it will be sent to a defined destination, which can be memory, the local file system, S3, or Activeloop cloud. And this process is inefficient, and this is why Hub comes in. Hub solves several problems and make this whole process more efficient. With Hub, you can use indices to create a subset of a dataset without any need for advanced computations. Hub also allows you to perform distributed writes on multiple servers via parallel computation, and Hub also allows you to easily scale computations to large amounts of clusters with the compute configuration of Ray. Hub makes the process of uploading datasets, making changes to datasets, running inferences on your datasets, and many other operations on a large dataset much more efficient. And with Hub, you can read a dataset from any index, and you can tell Hub to read images from the appropriate interval and send them to the appropriate server. Each server processes the data and writes the data to an output dataset when the processing is done. And the goal of Hub is to allow you to write code on your laptop, which you can then scale to a large amount of servers. And now that we covered how Hub is different than the status quo for processing datasets, let's check out how to use parallel computing to process the datasets in a much more efficient way. Parallel computing with Hub enables you to accelerate your data processing on local machines or in multiple clusters. It encapsulates all information required to either upload a dataset, make changes to a dataset, run inferences on a dataset, and many other operations. And the first step for running parallel computations is to define a function that will run in parallel by decorating it using add_hub.compute. Let's take a look at this analogy of making cookies to understand what is needed to make this function work. You will need to provide the following to make the parallel computing function work. First, you'll need to input a dataset, which is an input, and in this case, in our cookies analogy, that acts like the cookie dough. Then you will need an input iterable, which describes information that will be operated on in parallel. And you can think of this as a cookie cutter, as it shapes every single cookie dough piece into the desired shape. And then you need to have the number of workers, and in this case, and in this analogy of making cookies, that is like the number of trays, and as you know from making cookies in the past, the more trays you have, the more efficient your process of making cookies is. And lastly, you need to define the output, which in this case is the location of the oven. So all you need to do to process your data in a fast way is to provide the add_hub.compute function the following. First, a dataset, which is the input, then an input iterable, which describes all the information that will be operated on in parallel, then the number of workers, and then the output, which in this case is dataset_new. If you use one worker, the result will be the same as the first inefficient situation, in which there will be a for loop that will write every item from the dataset in order to change the image colors on one server. However, if you increase the workers to 10, your data is automatically distributed to 10 servers, and the final dataset is saved to dataset_new. Multiprocessing on a single machine allows you to upload data from your laptop and then get an immediate 8x increase in speed. And this number can change based on the type of computer you have. By the time of this recording, it's usually an 8x increase in speed. And when we execute a function in Python, it usually runs on a single thread. However, most modern processors can handle multiple threads at the same time. So, Hub efficiently distributes the work among multiple threads to speed up the entire process. Also, we partnered with Ray to allow you to scale multi-process computations to large amounts of clusters. You can create an add_hub.compute function with a compute configuration of Ray with just one line of code. And with that, you can switch from a multi-process computations to RAID distributed, which can give you an 8,000x increase in speed by using 1,000 nodes with 8 workers each. And RAID is a great cluster service which allows you to scale up your computations easily, and it integrates very well with Hub as well. You can keep everything just the same, and all you need to do is to create a new compute provider and pass the required information for the dataset processing to the RAID compute provider. And your code and everything else stays just the same. And lastly, here are a few best practices for running a parallel computing function. First, run a parallel computing function without RAID on a small sample of images, which is like 10 to 1,000 images, and see if everything is working well. Then change the compute provider to something like RAID and scale it up to 1 million images. And that's it for this quick tutorial on parallel computing with Hub.